All right, so hopefully everything has been pretty clear so far. This is where it gets a little bit tricky. And again, it's not that these problems individually are that difficult. It's more about deciding which method you need to use. And you'll see that in the next section as well, that when we start to put all this stuff together, it does get a little bit more complicated. But one of the things that we have to remember is permutations is where order matters. The order that we take things is very important. Now, we're talking about repetition. So like, if you look at this example, this is a great example. It says if you consider the letters E and E to be distinct, in other words, separate, because you see that they're different, not in your notes, but you see in this video that they're different colors. There are 6 permutations of the letters E, E, and Y. And notice they're just putting them in all different orders. And because the letters are different colors, they are different. But if you just made them black and made them the same color, then why would we need to rewrite E, E, Y? Notice we have E, E, Y, E, E, Y. Why do we need to rewrite that? So we've got to have a way to distinguish what happens when we have things that are repeating each other. So we don't need to have that. We don't need to label something twice that is already there. So there's a way that we can do that, and it's real simple. What we do is we take the number of permutations, or we do the factorial, so we have 3 times 2 times 1 on top, and then what we do is we take the number of times that something is repeated each time, and we put that factorial on the bottom. So as you can see, I'm going to go up to the top here with this formula, and it says permutations with repetition, the number of distinguishable permutations of n objects where one object is repeated this number of times, another is repeated this number of times. Basically what we're going to do is it'll be the total number factorial on top, and then every time that it occurs, something different occurs on the bottom, we will do as many factorials on the bottom. So for example, if something occurs 3 times, and we don't need to repeat it, we're going to do 3 factorial. And then if something else reoccurs 2 times, there's going to be a 2 factorial. So you'll do it as many times across the bottom as you need. If there's only one thing that's repeated, then only represent it the one time on the bottom. So for example, let's look at this example right here. It says find the number of distinguishable permutations of the letters in Michigan. So what this means is we're going to look and see how many times is a letter repeated. So I know that we have 8 letters here. So for sure on the top, it's going to be 8 factorial. But on the bottom, what we want to do is we want to divide out whatever is repeated more than once. Well, M's not repeated more than once, I is. And I is repeated twice, or it's repeated once. So there's 2 of them. So therefore, on the bottom already, we're going to need a 2 factorial. Now what we're looking for is anything else repeated? Is the C repeated? If it's not, then we're good. If H is not repeated, we're good. If G is not repeated, we're good. If A is not repeated, we're good. And if N is not repeated, we're good. So then this is all that we're left with. So once we see that we're left with this, then we can just finish that problem and divide out what we have. So 8 factorial is 40,320. We've done that quite a bit. And then 2 factorial is 2 times 1, which is 2. So our result is 20,160 different ways that Michigan could be scrambled without repeating, the ones where the I's are the same. Okay? So I want you to do this one on your own. This one's a little bit more difficult because you have multiple repeaters, but let's see if you can do it on your own. Hit play when you're ready. So when you look at mathematics, you have 3 things that repeat, the M, the A, and the T. So we have 11 total letters, so that's 11 factorial on top. And on the bottom, because we have 2 M's, it will do a 2 factorial. We have 2 A's, so it'd be a 2 factorial. And we have 2 T's, so it's a 2 factorial. If any of those were repeated, say 3 times, then it would be 3 factorial for that specific one. But notice we're multiplying all 3 of those together. So that's 2 times 2 times 2, which is 8. 11 factorial divided by 8 is 4,989,600. So again, it's not that these formulas are tough to use, it's more about knowing when to use them. So this is the case where if something is repeated and we don't want to represent the same thing more than once. Up here, these ones right here, we didn't really care about repeating as much. The order did matter on those. So the order was very important. So we just simply did formulas where we did the number of total things on top, and then whatever we were choosing on the bottom was going to be subtracted out. Okay, so that was helping us there. So it was 6 choose 4, so you did 6 on top, 6 minus 4 on the bottom. And then up on the first page, that's where we were just trying to figure out the total number of different ways we could do something, so that was just straight multiplication and we didn't have to do anything else. Okay, if permutations, if we're choosing all of them, then it's just the factorial. 12 times 11 times 10 all the way down. Okay, so hopefully, I know that's a lot of material, but I think the material is easy enough that we can throw a lot of things in there. So make sure you jot down questions and bring them with you to class if you need to. Don't forget to take your Edmodo quiz.